Hello, this is David Reevy, and I was going to demonstrate a few of the different pulse width modulation techniques that are available on the Arduino. The first one uses a function called analog write, which is very popular for controlling the speed of DC motors or the brightness of an LED, for example. And here in front of me I have the circuit set up so that as I turn this potentiometer, it is going to be read by the breadboard, which in turn will translate that to a value that is sent to the analog write function, and that in turn is controlling the pulse width here on the oscilloscope. You can see it here on the oscilloscope, and you can see the LED brightness changing. And right now it's at a 2.4% duty cycle, and as it goes up to here's at about 11% duty cycle, and this is 25%. You can see that as I get close to 50% duty cycle, that LED appears to be burning 100%, but it's only using 50% of the power as if I had turned it on fully, so it can act to conserve power as well. Now, some other forms of pulse width modulation used by the Arduino, or within the Arduino library, is we have a thing called the servo library, which allows us to control servo motors. And two particular servo motors of interest is one is your regular servo that moves 0 to 180 degrees, and the other is one called a continuous servo. Now, the continuous servo uses a function called write microseconds, which sends a pulse every 20 microseconds to the servo, telling it whether it should be moving backwards, forwards, or standing still. And the width of that pulse can vary, but in my case I was working with some continuous servos that would accept a pulse ranging between 1300 and 1700 microseconds. And I'm going to load that sketch down to the Arduino, and it's almost there now. So right now I just loaded a sketch onto it that is reading the potentiometer, and it's mapping that reading to range between 1300 and 1700, and then using the write microseconds. And you'll see where it's actually makes just a slight variance on the pulse width, but the scope is telling me that that pulse width is ranging between 1.305 milliseconds, which is 1305 microseconds, all the way up to 1700 microseconds. Now that, when provided to a circular servo motor, its circuitry will decide what it needs to do based on this. Whether it should be, if it's around 1500, it'll usually stand still, and as it moves closer to 1300, it increases its speed in reverse. And you have a similar action as it goes closer to 1700, it'll gradually increase its speed going forward. And again, that pulse is sent every 20 microseconds. Let me change my, right here, you'll see it's just a little pulse that contains quite a bit of information for the servo motor, and it's sent showing it going, well, here are the scopes showing the period to be 20 milliseconds, so you're getting 50 updates a second. Now, another type of servo is the one where you send it a value between 0 and 180 to tell it what position to move to. And I was curious what that looked like on the oscilloscope, so I'm going to upload a sketch which reads the potentiometer and then maps that value to a value between 0 and 180, and then uses the servo write method to tell the servo what position to move to. So I just uploaded that, and it looks pretty much the same as the other one, but let me break this out a little bit here and look at the actual pulse. It's still sending a pulse every 20 milliseconds. It's still sending a pulse, but this time it has a larger range. So let me cut that down a bit, about right there, make an adjustment there on my scope, and it looks like on the low end the pulse can have a width of about 545 microseconds, all the way up to 2,400 microseconds. So there's a wider range that the pulse width can contain when using the write method of the servo library, and that again is what I've commonly seen used to control your standard servos that move 0 to 180 degrees, and they do it with quite a bit of precision. And the other one is used for the write microseconds, is used to control continuous servos. But anyway, that's just a short demonstration of what you actually see when using the different forms of pulse width modulation on the Arduino. Thank you for watching. You have a good day.